In this section, we're going to look at solving equations by multiplying or dividing. So let's start off with an example. Negative 4 equals k divided by negative 5. So again, in these problems, you want to try and isolate the variable. But you can see that k is being divided by negative 5, and the only way to get rid of that division is to multiply k by negative 5. And if you multiply k by negative 5, you have to multiply the negative 4 by negative 5 also. The reason we multiply the k divided by negative 5 by negative 5 is when we multiply it by negative 5, we are able to cancel out the two negative 5's on the right side. So k is then left by itself. So now you have k equals negative 5 times negative 4, which is 20. And now we want to check this answer. So what you want to do is you want to take the 20 and plug it back in for the spot of k. So we have negative 4 equals 20 divided by negative 5. And when you do 20 divided by negative 5, you get negative 4, so we know that our answer is correct. Now we're going to look at another example of this. Alright, so m divided by 3 equals 1.5. Again, we want to isolate the variable m. So in order to do that, we have to multiply both sides by 3. The reason we multiply the left side by 3 is because when we do that, the 3's cancel out, leaving m by itself. So m equals 1.5 times 3, which equals 4.5. Now we want to check this answer again. So plug in 4.5 for the m. 4.5 divided by 3 equals 1.5. And when you actually solve out 4.5 divided by 3, you get 1.5, so indeed the answer is correct. Now we're going to look at solving equations by using division this time instead. So the example is going to be 7x equals 56. We want to isolate the x by itself. The only way to get rid of the 7 is to divide both sides by 7. You can see that on the left side, when it's divided by 7, the 7 and 7 become a 1, so that just leaves us with an x. So x equals 56 divided by 7, which equals 8. So you know that x equals 8. You can check this answer by plugging the 8 back in for x. So 7 times 8 equals 56. And if you plugged in 7 times 8 on a calculator, you would see that that indeed does equal 56, so our answer is correct. Now let's look at another example of solving equations by using division. 13 equals negative 2w. Again, we want to isolate the variable. In order to get rid of the negative 2, we have to divide both sides by negative 2. Because negative 2 divided by negative 2 would equal 1, leaving us with just 1w, which is what we want. So w equals 13 divided by negative 2. 13 divided by negative 2 can be simplified down to negative 6.5. Now, if we want to check this answer, we plug in our w value, which is negative 6.5, into the w spot. So 13 equals negative 2 times negative 6.5. If you were to plug that into a calculator, you would see that negative 2 times negative 6.5 does indeed equal 13, so our answer is correct. Now we're going to look at solving equations that contain fractions. Our example is going to be 5/9 v equals 35. In this example, you want to isolate the variable again. Because 5/9 times v equals 35, 5/9 and v are in multiplication, so in order to get rid of the 5/9, you must multiply both sides by the reciprocal, which is basically 9 over 5. The reason we are multiplying by 9 over 5 is because when 9 over 5 times 5/9 are multiplied, you get 1, which just leaves us with 1v, which is what we want. Now v equals 35 times 9 over 5. And when you multiply 35 times 9 and then divide by 5, you should get 63. Okay, we're going to look at another example of this. Solving equations that contain fractions. 5 over 2 equals 4y divided by 3. What we want to do here is isolate the y again. So first, let's start by, so you want to basically get 1y. So you want to multiply both sides by the reciprocal, so 3 over 4. The reason we multiply the right side and the left side by 3 over 4 is because when we multiply the right side by 3 over 4, we get 1y, which is what we're trying to reach. So we got y equals 3 over 4 times 5 over 2. Now we can just multiply directly across, and we see that y equals 15 over 8.